Is it audible?
Yes, ma'am.
Good afternoon, ma'am.
Good afternoon. Okay.
Good evening.
Yes. Basically, in the previous experiment, you have done the VI characteristics of PN junction diode and your Zener diode. All of you have completed both D1 and D2 group. I don't know whether you have shared your output to Siddharth sir or not for B1 group. I don't know whether you have shared it or not. But for B2 group, I got only 2 outputs. What about rest? All of you will do it and share it to me in the WhatsApp group, B2 group students. Okay?
Yes, sir.
Yes, reply, respond. B2.
Yes, ma'am. Yes, ma'am.
And for B1, I hope you have submitted the output and you have shown the output to Siddharth sir. So we'll move to our next experiment. That is your experiment number 2, which is, yes. Siddharth sir has created the link. Swastik, Satvik, you asked to Siddharth sir to, yes, ask Siddharth sir to join. Okay. Actually, I'm taking the lab for both the groups, so B1 and B2, so bear with the interruption in between, okay? So we are moving to our next experiment. That is your second experiment. The aim of the experiment is to interpret the principle of operation of transistor using its characteristics curve. Okay. So first of all, you tell me what do you understand by a transistor? What is the basic operation of the transistor? Any one of you?
Switching.
Switching and
Amplifying.
yes, basically the transistor is nothing but a semiconductor device that is used to amplify or to switch electronic signal or electronic signal. Yes. So basically this transistor are of how many types? BJT, you know?
Yes, ma'am.
You know BJT? What do you understand by BJT?
Bipolar junction transistor.
Bipolar junction transistor. What do you understand? Why it is called bipolar? Why it is called bipolar? Junction or
Ma'am, here we are using both electron and holes for that reason. Both the charge carriers we are using.
correct, Suparna. Basically, for B1 student, anyone can answer? Why it is called bipolar? Basically, yeah, partially correct. Both electrons and holes will act for the conduction in this, okay? Both electrons and holes will be taking part in the conduction, okay? That's why it is called bipolar. FET is unipolar because either your hole will be the responsible for the conduction or the electron, okay? FET is unipolar, BJT is bipolar. All of you understood this? All of you know this?
Yes, ma'am.
Yes, respond. Yes. So, what are the basic terminal of this BJT? How many terminals are there?
And 3.
3. What are those? Emitter, base, and collector.
Collector.
Okay. This BJT has 3 configuration. What are those? BJT is designed with the 3 configuration connections.
Common base, common emitter, common collector.
Common emitter, common base, and common collector. Basically, we generally use common emitter circuit for your amplification purpose. So what we are going to do, we are going to check the input and output characteristics of this common emitter transistor in this experiment, okay? So what you have to do, the input characteristics is considered between, let's say, just wait, I'll share my screen. For B2 student, is my screen is visible?
Yes, ma'am. It's visible.
For B1 student, is my screen is visible? My screen is visible? Okay. Okay, just wait. Can you see my PPT? Can you see the PPT?
Yes, ma'am.
Okay. Basically, these are the three transistor configuration: common base, common collector, and common emitter. In common base, base is the common terminal for both input and output. For common collector, the collector is the common terminal for both input and output. And for common emitter, the emitter is the common terminal for both input and output. Yes? All of you know this? All of you know this?
Yes, ma'am.
Yes. Coming here, this is the common emitter configuration. Here you can see, tell me this is which type of transistor, NPN or PNP? You can see my cursor? This is which type of transistor, NPN or PNP?
Ma'am, NPN.
NPN. And this is PNP, okay? This is NPN transistor, this is PNP transistor. All of you got it? Yes, respond.
Yes, ma'am.
Yes. Listen, for common emitter configuration, what we have to do, we have to check the characteristics of the transistor, input and output characteristics. Basically, the input characteristics is shows the details about the change in input current with the variation with the input voltage, keeping the output voltage constant. Okay? And the output characteristics give the plot between your output current and output voltage, keeping the input current constant. Okay? This is how we have to check. So, for common emitter configuration, can you tell me what is the input current and input voltage? This is the input part, this is the output part, right? Tell me what is the input current and input voltage?
Input current IB, input voltage VBE.
Yes. So basically the input current here is IB and input voltage is VBE. And we have to keep our output voltage as constant. Means we have to keep this VCE constant. Okay? And similarly for the output characteristic, what you have to do? What is my output current and what is my output voltage? Say. What is my output current and what is my output voltage for common emitter configuration? This is the output part, right?
Output current.
Yes. Basically, this IC is my output current and VCE will be the output voltage. And we have to keep our input current as constant. Means for output characteristics, we have to keep this IB current as constant. Okay. So what you have to do, you have to find this graph. You can see this IB is my input current and VBE is my input voltage. And we have to keep this VCE constant. For different value of VCE, we are getting this input characteristics graph. Okay. This is what you have to do today. All of you got it?
Yes, ma'am.
Yes. Coming to the output characteristics, here the output current is IC and my output current is IC and my output voltage is VCE. And we have to keep the input current IB as constant. For different values, constant value of IB, we are getting the characteristics accordingly. Okay?
Yes, ma'am.
Yes? Okay. Now, one more thing I have left. There are three regions of operation in transistor. What are those? What are those? It is written here over. Active region, cutoff region, and saturation region. Yes? All of you know this or not? So what happened in active region? What should my circuit will look like? For active region, my base emitter junction should be in which biased? For active region, my base emitter junction should be in which biased? Forward or reverse bias?
Forward bias, ma'am.
Forward bias. and my collector emitter junction should be in which bias? Forward or reverse?
Reverse bias.
Reverse bias. Generally, whenever we talk about the active region of the transistor, we consider the input side in forward bias, that is your base emitter junction should be in forward bias, and your output side should be in reverse bias, that is your collector emitter junction should be in reverse bias. Okay. Then coming to the cutoff region, what happens to my input base and emitter junction? It should be in which bias? Yes. Is it? Yes, tell me. B2 student? Any answer from you? Yes. Answer. Generally, when we talk about cutoff region, my input side and output side should be in reverse bias. And whenever we talk about saturation region, my output and input side should be in forward bias. Okay, remember this. And for active region, my input side should be in forward bias and the output side should be in reverse bias. Okay, got it? Okay, all of you understood. For active region, my input side should be in forward bias and my output side should be in reverse bias. For cutoff region, both should be in reverse bias, and for saturation region, both should be in forward bias. Okay? All of you got it?
Yes, ma'am.
Yes. Any one of you can tell me why, if I'll increase my VC, why this IB current is shifting to the right hand side, is IB is decreasing? If I'll increase my VC, why my ID current is decreasing here? Any one of you can answer this? Yes? From B1 or B2? Where? Who is answering from? You are from B1 or B2? Okay, Saurav. Yes, tell me, what is the answer? Where? In which part? Basically, what happens in your reverse, in the output side, you are giving a reverse bias, yes or no? Yes, in the output side, you are giving reverse bias to the transistor or not? As you are giving the reverse bias thing, what happens to your depletion region? Width of the depletion region increases in reverse bias? Yes. If my width of the depletion region will increase, then as this base part is having a very low concentration, yes or no? Generally, this emitter part is having high concentration of carrier. This base is having very low, and collector part is having a moderate concentration. Okay. As the depletion region width will increase, very less concentration will remain. That's why my ID will be decreasing. Okay. This is the reason. If I increase the reverse bias voltage, the ID current will go on decreasing. Okay. All of you understood this? Wait, someone wants to join, I think. Okay, coming to this output characteristics, can you tell me if I'll increase the IB, how my IC is increasing here? What is the relationship between IC and IB? Say, what is the relationship between IC and IB? Yes, anyone from you? B1 or B2? IC is equals to beta IB, you know. Yes, tell me, do you remember this or not? IC is equals to beta IB. This thing you know?
Yes, ma'am.
Current amplification factor or current gain for common emitter configuration. Yes, beta is nothing but your current amplification factor. IC is equals to beta IB. Yes. So what you have to do, you have to design the circuit for common emitter configuration and you have to check these two characteristics, okay? So what you have to do for the input characteristics, this is a BJT NPN transistor. I have given a base resistance of 1 kilo ohm and your collector resistance as 500 ohm, okay? I have given an input voltage as 12 volt and the VCC, that is your output voltage, as 30 volt. Okay, generally the VCE is greater. Okay, we use this as a greater value for the output side. So what we have to do, we have to check the input characteristics. Okay, is my screen visible to both the groups? B1 and B2?
Yes,
Yes. Yes, output side should be in reverse bias. Is it? It is reverse bias. Here it is N, right? I have connected with the positive side. This is in reverse bias. Okay, if I'll flip this, then it will be in forward bias. Okay. So basically, this is the your common emitter configuration. Emitter is common for both the input and output side. So what we have to do, we have to check the input characteristics for this. For checking the input characteristic, we have to keep this as constant and we have to check the value for ID and VD. Okay, we have to vary this and we have to keep this output voltage as constant. Okay, for this, what we will do, you can go here, interactive simulation. Okay, then go to DC sweep. From here, you can give the terminal values. You can see my input is V3 and my output is, I have given V1. You can also change the level of this, okay? Change the name of these voltages, okay? You can make it VBB and you can make it VCC, okay? Up to you. So V3 is my input and you can drop down this and you can change the values. I have kept the output voltage as V1. Here, what I am doing, I am giving the iterations, okay, to plot the graph. What we have to do, I have kept the value from 0 to 2, this is the start value and this is the stop value, okay. V3 is nothing but the VBE, the value of VBE that I am going to plot in the graph, okay, and I have kept the increment as 0.1 volt. Okay, if you want, you can take the screenshot of this. Okay, now I am taking the voltage, output voltage V1. Okay, I have kept the value as 0, start value, and I am keeping the stop value as 20, and increment will be 10. How many values I should get? 0, 10, and 20. So how many graph I should get? 3 characteristic graph, okay, one for 0 volt, one for 10 volt, one for 20 volt. All of you are understanding? Any doubt in this? If you want, you can take the screenshot of this, okay? Done? All of you have understood this? How to change the iterations?
Yes, ma'am.
Okay. Coming to, then we'll go to this output level. What I have to do, I have to check for IB current because I have already mentioned VBE here and VCE here. Okay. Now I have to check for the output current. What I have to do, you can see it is written here IB. You can see It is written here IB. Select this and just add it here. Okay. Select this and add it here. After this, what you have to do, you have to run. Are you getting 3 characteristics curve? You can see you are getting 3 characteristics curve or not?
Yes, ma'am.
Yes. So this is in black. This is with the black background. You can change the background from here. Click here. You can get the background from here. Okay. This is the input characteristics of the, your common emitter configuration BJT. Okay. So your work is to, what you have to do, you can change the value of register. Also, you can change the value of voltage according to you. Keep this VCC a much higher voltage than this, and do the input characteristics. Okay. Similarly, for the output characteristics, what you have to do, you have to replace this voltage source with a current source. Okay. In the same circuit itself. Okay. Replace the voltage source with a current source, because we are keeping our IB constant. Okay. So we'll consider this as a IB. Got it? All of you got it? Just what you have to do, you have to replace this voltage source with a current source. Then again go to this switch. Here I am giving the value of I. Here you can see the level is I1. You can change the value to IB. Okay. You can take the screenshot for the iterations. Take the screenshot for the iteration. I have kept this for 4 or 5 values, and V2 is nothing but my output voltage. Okay. I have given the iteration accordingly. You can change the value of this start and stop values and increment value. Okay, up to you. You can change it. Now coming to the output, as IB and VC are given, here we can see the output current as IC. IC is here, right? What we have to do, we have to select this and then we have to add it here. Okay. All of you are understood up to this step?
Yes, ma'am.
You are from B1 or B2? Both B1 and B2 student. All of you are understanding this? Yes. After this, what you have to do, again run this. You can see this is my output characteristics of common emitter configuration. Okay. Change the background. 5 values are there. For 0, this is coming a straight line, and rest you are getting the values. You can change the value. You can start the value for 1 or 2, or you can make it 5. Up to you. Okay. Can you do the circuit? Do not take these values. Take your own register values. Okay. Keep it higher, base resistance, and keep a smaller collector resistance. Also keep a higher voltage in the output side in comparison to your input side. Okay. First of all of you design the input characteristics and then show it to me. Okay. All of you go for designing the input characteristics first of all. Is anyone from B2 group you have completed the input characteristics?
Yes, ma'am.
Debesh, you have completed.
Yes, ma'am. Completed. Yes, ma'am.
Show it.
Yes, ma'am.
Why you have taken the same value that I have taken? No, I don't want to see this. You change the value and do your own circuit. Change the input voltage, output voltage, resistance value and do it by your own.
Okay. Ma'am, can I show?
Yes, Pradeep. Devesh, also write your name and registration number in the circuit. Also mention it that input characteristics of common emitter configuration.
Okay, ma'am.
Pradeep, you also write the name and registration number of yours in
Yes,
the
ma'am.
circuit.
Ma'am,
Okay.
this is the circuit. I have taken, ma'am, input voltage is 18 volt and resistance is 15 kilo ohm. Output voltage is 50 volt and the resistance across the collector is 9 kilo ohm. So when I plot the graph, it's coming like this.
How many plots you have? Okay, what are the iteration you have taken?
Yes, ma'am, I'm
How
showing.
many iteration you have taken? Just show.
Ma'am, for V2 I have taken start as 0, stop as 40.
V2 is what? V2 is your input or output voltage?
Output voltage, ma'am.
Output, okay. So you have taken, you can make it the increment as 10 so that it will be clearly visible. 5 characteristics you must get. Okay?
Okay, ma'am.
Now run this.
Yes, ma'am.
1, 2, 3, 4, 5. We are getting 5. The rest is the previous one. You can uncheck it, okay?
Yes, ma'am.
Okay. Now what you have to do? No, wait. Now what you have to do? In the taskbar, go to the right hand side, the second last icon.
This one, ma'am.
No, the previous one.
Oh, so second last one.
Yes, that is export to Excel. It will export the values to the Excel, okay? So click on that. So what are the value you want to take? 10, 0, 10, 0, 10, 10. Okay. Then 20, 30, 40. Okay. Okay. And Excel will be downloaded.
This one, ma'am.
This has been downloaded now.
Yes, ma'am.
So you can increase the value of the VBE. Okay. Increase the increment value for VBE so that it will be very clear. At least 10 to 15 values you must get. Okay.
Okay, ma'am.
So in your DC sweep, increase the increment value. Okay. You make it 0.2 or 0.1. 0.2. Make it 0.2. So it will be very large. Then export the Excel and then you will get the values. Okay.
0,
10.
20, 30, 40.
You can see this X trace is common for all the 5 column. Yes or no? 0,
Yes.
0.2, 0.4. You can keep one of the X trace and you can delete rest of the 4 X trace. It is not required because the X axis is common for all the characteristics, right?
Yes, ma'am.
Similarly, for VBB2, it is written above. You will do it later on, okay? While
Okay.
summation, you will do it. Just listen to me what I am saying. This
Yes, ma'am.
VB2 is 0, is equals to 0. You can see in column C.
Yes, ma'am.
For this 0 value, you are getting these number of IB's values, okay? These are the IB value. Y trace is nothing but the IB value for VCE is 0, okay?
Yes, ma'am.
Now, coming here to the F column, you can see VBB is
Equal to 10.
Equals to 10. Then this is VCE is equals to 10. And these are the IB values when the VCE is equals to 10.
Yes,
Okay.
ma'am.
Similarly, it will go on for 20, 30 and 40. Okay.
Okay.
So what you have to do, you have to, you can check also the characteristics curve in the Excel. Okay.
Yes, ma'am. By plotting that, ma'am, chart,
Yes.
scattered chart.
By plotting to the scatter chart, you can also check the your characteristics curve, input characteristics curve. Okay.
Okay, ma'am.
So now you can, this thing you will do it later on. This is nothing but your observation table. Okay.
Yes, ma'am.
This is the observation table. This is what you have to keep. What you have to do, you have to name this with the terminal VBE, IB, and BCE. Okay?
Yes, ma'am.
Just do not write this X trace, Y trace.
Yes,
Name
ma'am. I
it.
will make the.
Yes, Sangram, you can share your screen.
Okay, ma'am.
Yeah, run it. Write down input characteristics of common emitter configuration.
Okay, ma'am.
Right, run it. Okay, show me the circuit. Show the circuit. What are the values you have taken? Let me see. Show the circuit. Okay. I have told Priyadeep how to export the values of this characteristics curve. You have understood that?
Yes, ma'am.
You have to do it accordingly with the proper labeling. You have to mention the observation table. That is your observation table. Okay. Yeah. Go for output characteristics. Check all. Check all. Check all. Make it check all. Then you can do it. Yes. Keep one of the X-rays. Listen, replace this X-rays, Y trace with a proper labeling, okay? X-rays is nothing but your VDE, okay? Also mention it unit, volts, millivolt, whatever it is, okay?
Okay, ma'am.
Yes. Do it. You can also plot this using your Excel, okay? You can check the characteristics by using this value in Excel. Yes. Okay, you can stop sharing your screen.
And can I share now?
Yes, Devesh, share.
Ma'am?
Yes, Devesh, you can share. How many iterations you have taken? Show the values of your DC sweep. Show the values. 6 characteristics curve, 7 characteristics curve. 0, 10, 20, 30, 40, 50, 60. 7 characteristics curve.
Yes, ma'am.
But show once again, run this. We cannot visualize it properly. All the 7 curves are not visualizing properly. You can reduce the increment value, increase the increment value. For that, make it 20. No. For, yes, V2.
20.
Run. But why? Okay. Also, you reduce this x-axis increment. Okay. Increase it. Make it 0.5 or 0.2, like that. Okay, what you know how to export the values for this? You know how to export the value of these characteristics?
No.
Go, I've already told you. Go above in the taskbar in the right hand side, second last icon. Below that, yeah, export to Excel, okay. Check all the traces, check all. No. Make it, you have done the increment of 20, right?
Yes, ma'am.
Uncheck this 10, value for VV2 10. Uncheck this second row, uncheck this. For 30, uncheck this. 60, check. Okay. Unable to transfer the data to Excel. Why? Check the DC suite once again and try to download the Excel, okay?
Okay.
You can also reduce the start and stop value. Make it up to 3. Okay. Stop value, make it up to 3 and do it. 3. You do it by your own, okay?
Okay.
And go for output characteristics.
Ma'am, I have plotted the output characteristic graph also.
Okay, Priyadeep, wait. Okay. You have done it. Okay, fine, Devesh. Export it.
Yes, ma'am. I am downloading Excel.
Priyadeep, you have.
Ma'am, there seems to be some problem. I'm not getting the proper graph.
Chinmay. Okay, wait for a while. Wait for 1 minute. I'll get back to you, okay? Yes, Chinmay. Show. Chinmay.
Yes, ma'am.
Yeah, share your screen. You're getting only one value. Why? Show me the DC suite value, what you have taken. Okay, go to the output level. Output. It's the IP. Okay. Again, go to the analysis parameters. Analysis parameters. Okay, make the increment as 5. Make it 5 for V2. Now run it. Why it is slow? Okay, close this. V2 V1. Okay, again open the DC suite. Okay, make the V2 stop value as 20. Make it 20. Now run it. Why you are getting only one value?
I don't know, ma'am. I tried a lot.
Okay, what you have to do? Again go to DC suite. make the V1 stop value as 3. 3. Run once again. Again, you are getting one value. Okay, close this. Increase the value of collector resistance a bit. Make it 800. Collector resistance. Make it 800 ohm. Now run it. Directly run it from here. Why you are going to open that DC switch? Run it from here. Still you are getting the same value. Okay, make the circuit in another layout. Okay, leave this. Do not save this. Make the circuit in another layout.
Okay, ma'am.
Take the component. Do not copy this component. Take different. Anyone else wants to show?
I'm
Yes,
not
Suparna.
getting my DC sweep. Can you please help me out with this?
Yes, share your screen.
Yes, ma'am. And
Yes.
when I'm clicking on interactive simulation settings, like this window is coming. What I'll do next?
Okay, reset to default. Make it reset to default.
Yes, ma'am.
Mine automatically. Okay. Which version you are using?
Multisim 13.0.
13.0. Still is not coming. Okay, just wait. I'll check and get you back.
Yes, ma'am.
Okay.
Yes, ma'am. Yes, ma'am.
I'll check once.
Yes, ma'am.
Yeah, stop sharing your screen for now. Okay, can you go to the simulate? Go to simulate.
Yes,
Go
ma'am.
to simulate. There is, go to analysis. No, go to analysis. Yeah, go to
Yes, ma'am. Here this is it. Thank you, ma'am.
Click on that. Click
Yes.
on that to show. Yes, you'll get it now.
Yes, ma'am. Yes, ma'am. Thank you, ma'am.
This is for input characteristic. Ma'am, I don't know, for some reason, the same circuit I have drawn half an hour earlier, but it wasn't showing the result. And now you told Chinmay to do it again, so I also did it again in
You have done some changes with the components. I don't know what you have done. I think might be you have done some changes with the component, with its characteristics. That's why it was not working earlier. Okay?
only the straight lines.
Go for output characteristics.
Yes, ma'am. 1 second.
You can directly run it from there. No need to go to the
Ma'am, I'm
DC.
checking if it was correct. Yes, ma'am.
Okay.
Ma'am, shall I stop sharing?
Yes, export the values and do the tabulation accordingly, and also check the graph in the Excel, okay?
Yeah, ma'am, sure.
But take the graph of this multisim only, okay?
Okay, ma'am, okay, ma'am.
Stop sharing your screen. Okay, also you have to wait, and also you have to take the screenshot of your means your layout, multisim layout, okay?
Okay, ma'am.
Yes, Suparna, share.
Yes, ma'am.
Okay, Suparna, you know how to export the values?
Yes, ma'am. I've already done
Okay,
it.
so show the output characteristics.
Yes, ma'am. This one is the output characteristic.
You can directly run this, no need of going to DC switch and then run it.
Okay, ma'am.
Okay.
Even I've downloaded the Excel
Yes.
sheet also.
Yes? Okay.
Ma'am, I have downloaded the Excel sheet also.
Rename the labels of this, okay?
Yes, ma'am, I'll do that.
Huh.
Thank you, ma'am.
Yes. Anyone else wants to share their screen?
May I share?
Yes.
This is the input.
Yes, run it. Change the background. Export it. What is the output character? Don't export it right now. You will do it at your home. Show me the output characteristics.
Yes, ma'am.
Change the background. Okay. Swaraj?
Yes, ma'am. Struggling with online multisim.
Struggling with online multisim.
Yes.
How you can do the DC switch in online multisim? କେମିତି ହବ ସେଟା ପେ କରିବାକୁ ମାଗିବ ତମକୁ ହବ କେମିତି ତମର ଅଫଲାଇନ କାଇଁ
ପ୍ରୋଟିୟସରେ ବି କଲି ପ୍ରୋଟିୟସରେ ବି ହଉନି ମୁଁ ବି
ଆରେ ତମର ଅଫଲାଇନ ମଲ୍ଟିସିମ୍ ହଁ ବାହାରେ ଅଛ
ଡାଉନଲୋଡ କରୁଛି ସଫ୍ଟୱେର ଟା ନାହିଁ ମୋ ପାଖରେ ମୁଁ ଅନଲାଇନ ରେ କରେ ସବୁବେଳେ
ଅନଲାଇନ ରେ ସବୁ କମ୍ପୋନେଣ୍ଟ ନାହିଁ
ନାହିଁ ତ ମ୍ୟାମ୍
ତ ତମେ ଡାଉନଲୋଡ କରିକି ରଖିବା କଥା କାଲି ଗୋଟେ କ୍ଲାସ କଣ କଲ ତମେ ପ୍ରିଭିୟସ୍ ମଣ୍ଡେ ଦିନ
ସେଦିନ କରିନଥିଲି କ୍ଲାସ ଆଟେଣ୍ଡ କରିପାରିନଥିଲି ମ୍ୟାମ୍
ହଉ
ମୁଁ କରିଛି ଆଜି କରିଦେବି ମ୍ୟାମ୍
ଶୁଭମ
Yes, ma'am. 1 minute.
1 minute କିଛି ତ କରିଥିବ ଯାହା କରୁଛ ଦେଖ
Yes, ma'am. ଦେଖୁଛି। କଣ ପ୍ରୋବ୍ଲେମ ଅଛି କରୁଛି ପ୍ରେଜେଣ୍ଟ
ଓକେ
ମ୍ୟାମ୍ ମୋର ସିମୁଲେଟ୍ ହଉଛି ମୋର କିଛି ଆଉଟପୁଟ୍ ଆସୁନି
ଆଉ ଦେଖିବା ତମର ସୁଶୀଲ
ମ୍ୟାମ୍
ରନ୍ କର
ଇନପୁଟ ପାଇଁ ଇନପୁଟ ବାଲାଟାରେ ଟିକେ ପ୍ରୋବ୍ଲେମ ଅଛି
अगेन तमे आउथरे डिजाइन करो सर्किट हला अलगा लेआउट रे डिजाइन करी के देखियो आसीबा से न्यू कंपोनेंट्स नहीं के डिजाइन करो
ओके मैम आउटपुट टा ठीक आ जाउची
हां इनपुट ता करो पहले
ओके
DC sweep detail how?
The output and layout. तुम्हारा multisim schematic. हला all of you listen. What you have to do, you have to do the experiment and share it in the WhatsApp group of BS Lab. Okay. Do not share to my personal window. Share it in the DS Lab group. Okay. Make a PDF of your layout, output, and DC sweep values. Okay, and send it in the WhatsApp group. All of you got it by today evening. Okay.
Yes, ma'am.
Yes, sir.
Do it. Yes. Write your name and registration number in the chat box.